Today's lesson is about gravitational fields. Gravitational fields. This is one of the easy lessons. You can learn it within one day and score a good amount of marks. So let's get into it. So let's assume we have two objects. This is our sun, and we have a small object which is our earth. Okay, so mass of the large object is capital M and the mass of the small object is simple m. Center to center distance is given by capital R. So first topic we are discussing is gravitational force. Okay, so the force is proportional to the mass of the object. When the object is massive, the force is greater. That's why when we talk about the black holes and stuff, it's a interesting concept about black holes. They have almost infinite amount of mass, so they have a greater force and nothing can escape from it, including light. So when the mass is higher, the force is very high, and the force is also proportional to the other object also. So the force is also proportional to the smaller mass as well, but the force is inversely proportional to the distance square. Remember, all of these fields, electric field, magnetic field, gravitational field, whatever the field, they obey inverse square rule. Okay, so you can tie all this together. So force is given by capital M, simple M over R square. You can convert a proportionality into an equation, into an equal sign, by using a constant. That constant is capital G. Capital G stands for universal gravitational constant. Okay, next one we are going to learn is about the next thing we are going to learn is gravitational force. The next thing is gravitational acceleration or gravitational intensity. We can use a different color. Next thing we are going to learn is about gravitational intensity. Gravitational intensity, or in other terms, acceleration, gravitational acceleration. So when we consider Newton's second law, we know force is equal to mass into acceleration. We want the acceleration, right? So we will subject acceleration. Acceleration equals to force divided by the mass. The force is given here, capital G mm over R squared, and we are dividing it by simple m. So simple m cancel, and acceleration we use G, simple G, for gravitational intensity, capital M over R square. Okay, so this object is spinning around this object, so the gravitational intensity felt by this object is this. So you can see that it is independent of the mass of the object. Okay, so let's go to the other one. Next one is gravitational potential. This is the definition. The definition of this is given by work done to bring an object from infinity to a point in gravitational field. Okay, so we have our object capital M, and we have the other object, and we do some sort of a work to bring it from the infinity to a certain point in the field. So the equation is derived using integration. So we don't have to go to the integration. We can simply say that the potential, gravitational potential, we use V for this one, is given by minus G capital M over R. Remember, for the gravitational force, we used R squared. For gravitational intensity, we used R squared, but for here, it is R. And the minus comes because the field does the work. We don't do the work, the field. The field brings that object to the work. When it comes to other fields like electric and magnetic fields, that will change, and you have to consider who does the work and on what application it is given for. Then you will be able to do it. Okay. Next one, we'll discuss about gravitational potential energy. Gravitational potential energy. I'll repeat. Okay, gravitational potential energy. So now you might say you already know the equation. Energy is given by mgh. But this is wrong because the height is only for small distances. When it comes to celestial distances, like from planet to planet, the distance as the distance changes, the g also changes, because we know in the equation we have something like this. The equation for the gravitational intensity is this. So when the distance changes, this also changes. When two variable distance, actually if it increases, the gravitational intensity decreases. So when two variables are there in an equation, it's very hard for us to process it. So we have to reduce it to 1. So normally we know energy can be obtained by force multiplied to the distance moved. When an object is there, a force is applied and it moves a distance. The energy done, or the work done, or the energy expended can be obtained by force into the distance. Similarly, we already know the force of gravitational force is capital G, capital M over R squared, and multiplied by the distance between the planets. We use the distance between the planets, which is R. So this square and this R cancel. Finally, we have capital G M over R. This is also minus because the field does the work, not us. Okay, that's it for the gravitational fields. If you have any doubts, you can leave it in the description, or if you can WhatsApp me.